So today we have a very important topic to discuss. The first 2 weeks we dedicated to morality. I don't know how much you remember, but we talked about trolleys and all sorts of things that impact our empathy towards others and how we think about whether we should help or not help. Do we have an obligation? What's the difference between action and inaction? Things contrasting utilitarian and deontologists. So all kinds of different perspectives going all the way into self-driving autonomous vehicles and all this. We're going to take a step back from all of that and put morality aside for a bit. We're going to talk about something a lot more fundamental. We're going to talk about how we know what is credible evidence. So in order to address this topic, I need to share with you a lot of the things that I do and a lot of the pressures of the environment that I'm in. Some of this maybe you're familiar with. I'm just curious, how many of you are doing a thesis this year? Are you doing a thesis? Anybody doing a thesis? Some of you are, okay. Any interns doing an internship, research internship? Some of you are, okay. So seems like you're doing your own research or you're part of a lab that does have a research culture which affects you. There are some expectations of you to act in a certain way or do research in a certain way. I definitely have a lot of pressure on how I conduct research. It has influenced me since the beginning of time when I decided that PhD is something that I want to pursue up until now. So I'm on a tenure track, the last year of my tenure track. And throughout these whole years, from the PhD to a postdoc, to a second postdoc, and then a tenure track, this whole time I'm under a lot of pressures because I need to get into a PhD program. I need to find a postdoc. Then I need to find a second postdoc, and then I need to get hired as a tenure track. And finally, I need to convince the university that they should give me tenure so that I can get promoted. In order to make all this magic happen, I also need to convince the funding authorities, in this case, the Hong Kong Council, the grant funding authority, to give me some money in order to run my research. Without money to run my research, I cannot have a lab, enough people, enough funding in order to run the stuff that I need to run. So I want to discuss all these things with you. And because a lot of you are doing interns and doing thesis, this has direct implications on you. I don't know why, but we don't discuss these things with you enough. Actually, most common is we don't discuss these things with you at all. So I'm hoping that you've heard about some of these things, but I have a feeling you might not have. And this presents a lot more complexity into what research is. So a big topic in our semester and the first two tasks, now you know because you've done the team contracts, is that we're going to discuss what is credible evidence. We're going to write a book together in order to assess what does it mean when I see a piece of information to know whether this is credible evidence or not. Before we even go there, we need to have an understanding of how we do the research process here when you submit to my course or some other courses, when you do your thesis or intern, what is expected of you. And then as you do the literature review, as you write, as you design your methods, how do you know what to do, what is credible, what to build your research on, right? So I'll start with one very basic question. Hopefully you can share some of your insights from your research process. When I want to know what to do my undergraduate thesis on, I have a topic in mind, but I want to know, is this a solid direction? Is the literature okay? What finding works and what doesn't work? What should I do? How do I know what is the status of science in my field, in my research question? How to address this? What would be the first thing that you want to do to get an overview, a general understanding of what to do, what to look at? What should we do? Google is a good start. I go to Google, google.com, then what?
Search.
So tell me how to do it. How do I search?
Type.
Yeah. Can we have an example? Let's take an example. What's a research topic?
We are interested in uh, equality.
Equality, terrific. Very good topic, very related to social psychology. I want to know about equality. So I go into Google and I want to search something about equality. What do I do? What kind of things should I write for Google?
Put the key terms. Okay.
Key terms? Yeah. Equality, for example, a lot of variations of equality. Then what? I get a list of like 10 million results. What then?
Try to narrow it down.
Yeah. Tell me how. What should I do? What's narrowing down? Not specifically on the spot, like anybody who has anything to offer. How to narrow this down? 10 million. I want to narrow it down to maybe 5 or 3 that I should read, right? What other keywords can I use? Best evidence, right? Yeah.
And then here.
Then the year. Everything 2003. Okay. Why is it 2003? You mean most recent or from a certain period?
Yeah, awesome.
Okay, from a certain year that you think is more recent or more up to date. Okay, good start. So we have a first keywords around the topic. Then we want something related to evidence. We don't know exactly what the keywords for that. And then maybe we have some things that we say, okay, we want the most recent stuff, right? So very good start. But this is still going to give me like a lot of, especially equality. That's going to be a big topic. And it's not even related to psychology. You know, you've got equality in almost every possible field in the social sciences, but we want something about social psychology. But yeah, we have different levels of evidence. So for example, we have experiments, we have surveys, we have observational data, we have archives, we have qualitative, we have quantitative. We have a lot of these kind of keywords. But if I want to have a general understanding of how things are going, typically we start with two very high level stuff. So we want to see a systematic review, perhaps something that is very recent. So we want up to date systematic review, not just any review, but a systematic review that goes over things very, very clearly, step by step, and makes sure that they covered everything, the published and the unpublished. And another thing is that if we want some quantitative data about what is the impact of equality on something, then we write equality on whatever the dependent variable is, and then we write a meta-analysis. And a meta-analysis allows us to see an aggregation, right? Now, I want to ask even beyond this. So let's say, for example, we care about equality, and we care about also loneliness or mental health, and we care about everything in social psychology. And now I want to know how good, credible, how well the science is functioning in all of social psychology. What can I do? What can I look for? So we have a lot of topics, and then we have a lot of results for each one of these topics. And then we know that, okay, meta-analysis works to get you started. Systematic review gets you started on a very specific IV, DV, independent variable, dependent variable. Then how do I aggregate this even further? We started a whole field. A lot of social psychologists are in this field, but it's not directly related to social psychology. And we call this meta science. So what meta science does is it applies scientific principles to the study of the scientific process. So in order to know whether science works, we need to use science to test it. So sometimes one of the things that we do, and I'm going to show you a lot of meta-scientific evidence, is we look at a lot of meta-analyses together, and then we aggregate them all together in order to see whether there's a certain behavior. If scientists do X, how does this impact the results? Or what can we see that happens? And suddenly you start to notice a lot of things about science that you did not notice before. Meta-science is a very young field, maybe 5 years, but a lot of researchers are realizing that we have a lot of problems because in 2011, social psychology was one of the first sciences to realize that we have a problem. At the beginning, everybody was saying, of course, it's social psychology. We don't care about social psychology, and social psychology is not a real science. Therefore, forget about it. All the other sciences are amazing. But then, starting in 2015, social psychologists went to the other sciences and said, you think you're amazing? Show us, give us meta-scientific evidence. And then we realized that a lot of the issues that we found in social psychology actually happen and are far worse in other fields. So I'm going to present some of this to you so you have an understanding just how well science is functioning, not just in social psychology, but also in other fields. Okay? All right. Why does this not work? It works. Okay. So just a basic statement. I hope that we can all agree on this. We have a lot of challenges. We just came out of a pandemic that nobody seems to remember anymore, where we faced global issues of how do we overcome this pandemic? What should we do? Social distancing, vaccinations, ventilators, all kinds of things that we needed to address. Suddenly it faded. Still need to understand what exactly happened over there, variants, you know. But then we also have other things like climate change, the rise of AI and what's going to happen with AI as people adapt. Misinformation, big topic, social psychology. A lot of these relate to social psychology. But for all of those, we really need credible, optimized science. If we don't have optimized science, there's very little that we can do in order to address these. We cannot use our gut intuition. So we can start from the basic understanding that we have to have credible, optimized science in order to overcome things like pandemics, like global warming, climate change, like misinformation and AI. So first question we want to ask ourselves, how is science doing? We had some opportunity to evaluate this during the pandemic. What did we learn? Actually, we learned things that were not good to hear. I'll give you an example from cancer biology. So we're not talking about social psychology anymore. Maybe if somebody doesn't implement my interventions, maybe no big harm. Cancer biology. I think all of us know somebody or have heard of somebody that has cancer. Perhaps we're worried about us getting cancer or a family member getting cancer. It's something that all of us care about in a society. We want to know if treatments and interventions in cancer biology work. If they don't work, we're in serious trouble. How do we know whether something works or not? We try to run the same thing that was published in an article again. And we want to see first, are we able to reproduce to see exactly what it is that they did and do every step of the way? Second thing we want to test is whether we're able to replicate it. So the original findings map to what it is that we find in our replication. So a team, because social psychology had some findings in 2015, which I will show you, this same team with the Center of Open Science decided to also do some replications in biology. So this is the general outline. It's a little bit small, so I'll walk you through this. They designed 193 experiments. They went to cancer biology and they said, in cancer biology, we want to know about the most important 193 experiments. And these are the ones that we're going to give to labs from around the world to run again. So they designed 193 experiments. However, already in the first years, they had a big problem. The big problem I think we're all familiar with if we ever read an article. When you start reading an article, it's actually not really clear what they did. Social psychology is a little bit better because it has a little bit, like it has the scale, so you need to look up the scale. It has a little bit of a description. But cancer biology, how to run the experiment, you need a whole procedure, and sometimes the protocol is not in the article. What do you do? Out of those, only 87 had the entire protocol for them to be able to begin. Yeah? But not only is this a big problem from 193 to 87, that the article is not clear enough. The article is not clear enough in the best of journals about cancer biology. So you want to design treatments, interventions, medicine, you can't just go to the article and do this. This is already horrible, even more horrible than this. They said, okay, it's not the protocol. Let's email the professors, the scholars, and just ask them what the protocol was. And then what do you realize? The professors are very much like students. The dog ate my homework. I lost my laptop. My email was hacked. I moved universities. A lot of excuses for all sorts of things that make absolutely no sense. So it's not just the articles don't do well. Us researchers, we don't document things. We don't share things. We lose things. And then we behave like little kids as if this doesn't matter. This matters a lot because it's cancer biology. We want to know that we can treat cancer. So come on, you cannot lose this kind of data. Okay, so we started from 87. Then what? Actually, the number of experiments that they were able to start was just 50, because even in the protocols that they were able to reproduce were not clear enough. They started doing the experiments and they realized that in the experiments there are lots of complications, and suddenly it's not really clear. Wait, what did you do? For how many minutes? On what substance? At what point did you administer this? What did you test? How did you measure this exactly? With which instrument? Does this instrument still exist? Perhaps it's a different thing. So out of the 193, they only ran the 50. Okay, so let's say lots of issues there. We can try and kind of overcome this. Maybe not important, as long as out of the 50, we get very high replication rate, right? If we get 100% of the 50, then we're all, set. At least we know that the ones that we're able to reproduce replicate very highly. What replication rate would you expect? You're the taxpayers. You pay these researchers. They are able to do what it is that they do because you pay taxes. So what is the replicability rate that you would think is decent? Some people say, okay, maybe not 100, maybe some mistakes, maybe there's all sorts of things. 90%, 80%. What's the bottom line? What is the replicability rate of these? So unfortunately, you can see the summary table over here, succeeded on all three criteria, which is the criteria that we aim for. So here we have 11%, 6%, 13%, 18%. A summary by one of the top researchers that did this on Twitter as it was unfolding. Starting from 2013, 50 cancer. Then, sorry, we can only even just, do the entire procedure, 18 of them, 36%. By 2021, which is when they finished the whole thing, how many fully replicated? 5 is full replication out of the 50. Partial replication, 7 out of the 50. The other is not reproducible and not interpretable. Look at these rates. This is absolutely horrible. Everybody was just horrified by this. This is cancer biology. This is the top that we have. This is in medicine. Billions of dollars invested in this. A lot of interventions and a lot of medicine came out from this body. If cancer biology has this kind of problem, first, we cannot reproduce. We don't understand the articles. We can't reach out to the authors and get clarifications. And then at the end, we can't completely replicate these things. So 5 out of 50 or 5 out of the 193 over here. Absolutely horrible. Now, even more than this, in the ones that they replicated, it's not that it was the same impact, but actually it was 80% less in terms of the impact, 85% smaller than the median effect size in the original articles. So let's say that you have an efficacy, something is supposed to help you with cancer. Actually, no, it's 85% weaker than that. 85% weaker than that in the things that work. It's shocking. We saw this come out. I would expect HKU to stop everything and just say, hold on. We need to reevaluate everything. We need to take a step back and understand how researchers are doing their research, because something here is very flawed. At the very least, we need to understand, why is this happening? How could it be that it's this bad? With all the billions wasted, we need an explanation for this. What is the explanation for this? So the issues that cancer biology has shown here are very, very big. But then you can say about cancer biology just what you said about social psychology. Cancer biology, complicated people who go to cancer, maybe only. Forget about cancer biology. The rest of medicine is perfect. The rest of sciences are perfect. But then this is just a case study. And actually, I started to collect a lot of these headlines. And it's headlines that we don't see a lot in Hong Kong. We don't talk a lot in HKU. We don't discuss this in undergraduate classes. I don't even know. Sometimes I give these classes to PhD students and they're like, what? What are you talking about? We just finished like 3 degrees already and we never heard of this before. Like, yeah, we should be communicating this because this is happening. So it's not only cancer research is broken. This is the most recent one from 2022, but also we have a general problem with medicine that the science stopped working. And this is from 2017, chemical research. We've got even computer science has a problem in reproducing things, quantum computing in physics, in economics. So all these different disciplines, this is not a social psychology problem. This is why we need meta-science. Social psychology was perhaps the first to indicate these kinds of problems, and I'll tell you why. But now we understand this is not social psychology, this is not cancer biology, this is everything in science. We need to understand what's happening in science. What did happen in social psychology? So 2011, I'll tell you later why, we decided that we need to check ourselves because some things seemed very, very fishy. So we started to do replications. And the first big atomic bomb exploded in our face in 2015. So we don't get to publish a lot in Science and Nature, but this one was published in Science. 100 labs from around the world tried to replicate 100 studies in social psychology, social and personality psychology, cognitive psychology. So we went to our best journals. I don't know if you're familiar with these journals, but in social psychology or any kind of psychology, we really care about psychological science, one of our top journals. In social psychology personality, we really care about Journal of Personality in social psychology, high impact. So we went to these journals, we picked the top of these published in recently from 2009, and we just tried to repeat them again, just like the cancer biology did, but only a lot earlier in 2012. So we ran this, and the first one came out, and we were just baffled by what we found. So only a third of the findings were successfully replicated, and in the third that successfully replicated, the effect size was about half of what was originally published. A third of our top journals. So we thought, okay, it's a social psychology problem. Maybe the journals are not high quality in psychology. If something is published in Science and in Nature, then it has to be solid because these are the highest impact factor. So they decided to run 21 of the social psychology studies that were published in Science and in Nature. How many of them successfully replicated? 13. There as well, half of the effect size. So we started doing a lot of these collaborative projects. Many labs 1, many labs 2, many labs 3, the big science collaboration. This one here is the summary of the many labs. How many replicated? This is the summary by Brian Nosek. He's the coordinator, the executive of the Center of Open Science. He's one of the first to try this on a mass scale. He's coordinating this, also giving solutions. His summary, 90 out of 190, 47% of the top journals of the Science and the Nature and the Psychological Science and the JPSP, 47%. I was in my first year of a postdoc. After I saw this, I stopped everything, not doing any of my research anymore until I understand this. Many went on with their lives. Oh, it's anecdotal, nothing to, these replicators, they don't know how to do research well. If you give this to the original authors, then they will find these effects. But these replicators, these people, they don't know how to do science. My summary for this whole thing, of everything that I've seen in my field of social psychology, is the replication rate is somewhere between 30% and 50%, depending on all sorts of things, and that the effect size is about half. of what was originally published. These are the common objections that I receive when I give talks about things like that. Some people are saying, this is just about psychology. As I've just shown you, this is not a psychology problem. This is cancer biology, chemical research, and so forth. So this is absolutely wrong. People say this doesn't affect me. If you do science or you consume science, and all of us consume science, that this should worry you very, very much. Some people say, in my department, some of my collaborators or people that I know say, but I know that my research replicates. And my question to you is, how do you know? Did you run a mass replication? Do you have some kind of an objective, independent criteria that evaluated your research? How do we know? Some people say, we have hundreds of publications, then it must be true. A lot of undergraduates that I see, I ask them, why did you choose this thesis direction? They say, yeah, we did a Google Scholar. We went to Google, and we saw a lot of articles, and they had a lot of citations. A lot of articles plus a lot of citations equals success. Really, unfortunately, this is not the case. You can have thousands of citations, and I'll give you some case studies where it just doesn't work. Then people say, I personally ran this many, many times, therefore I know this is true. Unfortunately, because of a lot of biases, and now that we understand this with meta-scientific evidence, we understand that the fact that you found something again and again, or that you think that your lab found something for you again and again, does not mean that this is actually solid evidence. So a lot of objections, and all of them are absolutely wrong, and we have the evidence to show that these are wrong. So question that we need to ask ourselves is, why is this happening? And at the beginning, we had no idea. We really needed to go back, and as psychologists, look at ourselves and understand the psychology of research and the psychology of researchers in order to tap into the mindset of what goes on in the research project. So first and biggest problem that we have, and I feel this very, very strongly every day, is that on one side, we've got researchers, and we really want to do solid science. We care about everything. We care about things that are of interest and coherence, novelty and replications. We care about collaborative. We care about doing things well. We care about replications. We care about striving for knowledge. We care about research done right. However, we're not incentivized for research done right. We're incentivized for all of this stuff. How to get published in the high impact factor journals that HKU cares about? It needs to be groundbreaking, sexy, trendy. Always has to be p-value lower than 0.05. You have to find something. Not finding something is not a contribution. It needs to rock the field. Novelty is super important. If you don't have all of that, if you're not able to shock the field and show something that's counterintuitive, that is novel, that nobody has shown before, then you're not going to get into the top journals. So everything is supposed to be novel. Everything is supposed to be p-value lower than 0.05. Everything is supposed to shock you. So you look at the literature, nobody does replications. Why do replications? You're not going to get into the journals. You're not going to get. If you found something, it's more likely that you'll get in. If you didn't find anything, you could spend an entire year doing a thesis as an undergraduate, and at the end, some stuff works, some stuff doesn't work. Many times, most of the stuff doesn't work, not because you're an undergraduate, because this is research. This is the randomness of the universe. This is how research happens. But we don't communicate the null effects. So there's this strain. And I feel this strain because everything that I do is impacted. Every time I have an evaluation, somebody sits with me and says, replications, come on, man. You're not going to get into the journals like this. You're not going to get promoted like this. This is committing academic suicide. You need the novel stuff. You need the groundbreaking stuff. You need the high impact factors. So I feel this every day, every day. Give you this example as a top one for you to think about. We at HKU need to hire people. So perhaps some of you are considering to go to a PhD and you're thinking, what is it that I need to do in order to finish the PhD successfully and go for the job market? Or even go for an MPhil and continue for a PhD. Anything that has to do with academia. We've got two candidates and we need to choose between them. Who should we hire? Who should we bring into HKU? And this seems like a no-brainer. For a very long time, we looked at this and we said, no problem. What is the dilemma here? We have two candidates and they have exactly the same resources. So let's say two PhD students and they have access to the same kind of participant pool. So they get 2,000 participants per year. They have about the same kind of hypothesis. Half are true, half are not true. Decent error rate. Comparable research design, let's say both of them are experimental. And then we have typical effect sizes. So 0.5, which is, it's not typical, it's a little bit high, but let's go for that. And then we have candidate A that published 33 statistically significant papers. And we have candidate B that published 21 statistically significant papers. Which one would you hire? What is the no-brainer here? Which one to go for? How many of you think candidate A? Raise your hand. Candidate A? Yeah? Some of you? Good. How many of you think candidate B? Raise your hand. None of you? None of you. Yeah. So seems like there's nothing to think about too much, right? I can definitely tell you, not just HKU. Every self-respecting department will go for candidate A. Candidate B, you should have done better. The A is outperforming you. What is the catch here? What are we not thinking about? So a lot of people have trouble, not just you, also professors. When I show this to professors, it's a no-brainer for them. Of course, candidate A, no problem. The problem is that if they have comparable resources, then they allocated their resource differently. How did they allocate these 2,000 participants? In order to get this 33 statistically significant paper, this one ran only 25 per condition. Comparable designs, you have to make some, you need a lot of papers to produce. Therefore, you run smaller samples with much higher variations and error rates. This one said, no, I want to be more credible. I want to make sure that the error is smaller. Therefore, I will invest the 2,000 participants in doing more per condition. Does this have any implications? What are the implications for this? So if we use a little bit of math, not too complicated, but if we convert this, and if you want to know how they converted this, you can go to this paper in SPPS, and you realize that actually candidate A has a 15% rate of false positive and replicability rate at 25% because the samples are very, very small and noisy. So the chance for replicability is not very high. However, candidate B, which invested more per condition, lowered the false positive rate to 6%, and then replicability risen to 76%. So suddenly, this is a lot clearer. It's hidden behind a different number, and the number is more about the number of published papers, but the credibility behind them is very, very different. So we can't just look at the number of articles published. This is not enough. We need to understand what's happening behind it. What kind of decisions do people do in order to get to these kinds of papers, right? So many factors contribute to credibility, not just the number of papers published, and sometimes the number of papers published can indicate lower credibility. If you see a professor that publishes 1,000 papers a year, you should be very, very worried. It means 3 articles per day, right? You're laughing, but we do have these kinds of very prolific researchers. Actually, think about it. How long does it take to work on an article? So what would you expect? Anything above that number, so let's say 3 weeks for a paper. So calculate how many weeks are there during the year, and then divide this by 3, and then see number of papers seems reasonable. Yeah, maybe if you collaborate a lot, you increase this by a little bit. Some of our labs in some of our departments, oh my gosh, the number of publications come out. It's very good. You get a lot of citations. HKU goes up in the rankings. But what's happening underneath? Does this researcher really read and understand each one of the papers that he has his name on or her name on? So one of the problems, a big, big problem, is with this obsession with impact factor. Impact factor. So I am evaluated on 2 factors, impact factor and number of publication. Number of publication, we already see there's a little bit of a problem there. Impact factor is also a very, very bad measure. First, the measure is per journal. It's not about the specific article, but then it's a product, and this product can be manipulated. And actually, journals manipulate this all the time. They can even negotiate their impact factor. And they do all sorts of things in order to increase their impact factor. Sometimes you may have seen online first. What is online first? Who invented the online first? Why not just publish this whole thing? Because they want to get a few more citations in before it officially becomes a publication, and then they have more for the 2 years that the impact factor calculates your citations on. A lot of them do special issues, so they get a lot of very high-profile researchers. Sometimes HKU also does this. Instead of getting good young scholars and getting to train them and promote them and build their careers, let's just get a Nobel Prize winner, 80 years old, bring him to HKU. He will bring all his citations with him, and then finally we can get a boost in the way that we do on the rankings, QS and Times Higher Education and all this. James Heathers, he's considered to be a data thug. He investigates fraud and all sorts of other stuff. He gives this excellent lecture on impact factor. Based on his lecture, I also give lecture on why impact factors are bad. I gave the first one last year at the week of open science at the library. There's going to be another one at the end of October. You're all welcome. It's open for everybody. And then I will talk about a lot of the things about why impact factors are bad. Nobody at HKU wants to work with me on this, aside from the librarians, because they have a sweet soul. and they're naive, and they only care about how much money they need to spend in order to buy the access to the journals, which I'm going to talk about next. But
hey, Christopher.
hold on.
Yeah.
This guy over here is a science communicator. He's actually a doctor, and he talks about a lot of things that go wrong in medicine. My sister is a medical doctor, and she finds all of this absolutely hilarious, but he also talks about the wrong things that happen in science. So here he talks about what I feel every day regarding the process of submitting to these high impact for-profit publishers. Very, very painful. This is what he has to say.
What do you think about making some of our articles open access? That's a good idea. Make the articles free to the public so that anybody can appreciate the latest scientific advancements. I like it. Of course, the author would have to pay some kind of publishing fee. Yeah, okay, that's reasonable. What, like a couple $100? Yeah, I was thinking maybe $11,000. What? Yeah, $11,000, and we put your article on our website for anybody to read. Why so much? Oh, you know, all the costs. What costs? Reviewing the article? Yeah, we don't pay reviewers. We guilt them into it because it's good for science. Okay, what about formatting? Your 12-year-old niece does that for us. Well, we gotta publish it. That costs money. It's a PDF on a website. Kaylee does it in like 2 seconds. Kaylee? Your niece. Oh, yeah. Besides, who's going to be able to afford this? Oh, people will pay. Why? Because they have to. What do you mean? Researchers have to publish in order to keep their jobs or get promoted, and we're one of the most prestigious journals around. People will pay. So it's extortion. Here at Nature, we're doing crime. Oh, Christopher, don't be so dramatic. So let me get this straight. You want to charge researchers $11,000 to publish an open access article, thereby ensuring that only researchers with the most money get to publish an article, which defeats the purpose of having open access articles in the first place. Yeah, that's right. And this is guaranteed to be profitable because researchers' livelihoods are dependent on a predatory system that values publishing in high-impact journals. Hey, you got it. This, of course, is insane. It's academics, baby.
Yeah. It would be funny if it weren't so sad. You are the taxpayers. You pay for this. Do you know how much you pay each year for the for-profit publishers? There's about 6 of them. The biggest ones are Elsevier, Springer Nature. You have access to this because you're in the HKU VPN. You're on campus. If you try to access some of these articles from outside, let's say during COVID, you want to know what vaccine works. You try to access an article, ask you for money, not small money, a lot of money, like $30-something, sometimes going up to $1,000 for a few days of access, right? You don't need to do this. Why don't you need to do this? Because the librarians pay for you. Do you know how much they pay for it? And then I did some estimation because they wouldn't tell me directly, so I go to the reports and read on the websites. And what's amazing about this is that subscriptions, which they pay, plus open science fees that researchers pay, altogether amount to, across all the Hong Kong universities, 2 billion Hong Kong dollars a year. 2 billion Hong Kong dollar a year. Do you know what we can do with 2 billion Hong Kong dollar a year? So you would say, maybe it's worth it. Maybe they give me some value. They do not. Everything that for-profit publishers do, we can do better, a lot better. We have different solutions for all of that. The only thing that we're paying 2 billion Hong Kong dollars a year in Hong Kong is for prestige, reputation, high impact factors. Makes me want to cry. Think about all the scholarships that we can give, all the funding that can go to research, all the labs that we can open, all the people that we can invite into the education system to give you better education. All this goes to profit share. Some companies in the US and the Netherlands that benefit from you. Now, nobody can fight this here in Hong Kong because we're relatively small. You think 2 billion is a lot? 2 billion Hong Kong dollars is nothing compared to what the European Union and the Americans pay. This is a scam. It's unbelievable that we take part in this.
Hey,
So it goes on and on. One of the first to do something about this was the European Union and the Dutch. They said enough with this. Because of that, Trump wouldn't do anything about this, but one of the first things that Biden did coming in is saying, we need to control this insanity. So at least the stuff that we publish with funding from the government should be free. So they gave out an order. But for-profit publishers are much more clever than policymakers and us. They have lobbyists first in order to argue, to make sure that legislation doesn't go through. But the second thing that they can do, they can mess around with the rest of the world. And then comes this absurdity. They triple, quadruple the fees for everybody else. So once Biden came out with this kind of stuff, the rest of the world had to pay more. Who's paying for the Americans? You're paying. You're paying for this. So this is the reaction from the for-profit publishers.
Hey, boss, Are you okay? Yes, Christopher. Why do you ask? You're ripping out pages of a journal. Yeah, because it's worthless, Christopher. Okay, what's going on? The government has decided that we can't make people pay for research that was funded by the government. That's a bad thing? Yes, the entire academic publishing business model is making taxpayers pay for things they've already paid for. But that's so unnecessary that there's no reason for that business model to exist. Of course it's unnecessary. Look, you don't get on the cover of Middleman Monthly by being necessary. What are my fellow middlemen going to say when they hear I've been cut out? I don't know. That's the number one rule of being a middleman. You don't get cut out. I'm so sorry. I don't think you mean that. No, I don't. We've been gatekeeping academic research for far too long. Things need to change. Oh, don't be dramatic. We don't gatekeep research. Yes, we do. You even named the company softball team the Gatekeepers. Well, if we can't profit off of publicly funded research, how are us lowly publishers supposed to make ends meet, Christopher? We make billions of dollars every year. I think we'll be okay. Yeah, for now. Within 5 years, our profit margins could go as low as Google. You know, this is a good thing for society. It gives the public more access to the latest scientific advancements. Well, I hope the public enjoys their free randomized controlled trials. Because I am about to create open access fees that are so egregious. It'll make United Healthcare blush.
Yeah, very sad. So, for example, some of my colleagues here in Hong Kong collaborating with people in China, talking about something very important like computational psychiatry in China, publishing in Nature Human Behavior, which we really aim for. So my summary for this big topic, it's a big problem in publishing that nobody wants to talk about, is that these are parasites. We need to get rid of these parasites, but we can't because our reputation, HQ, when we compete with the Americans, we need high impact factors in order to get the funding from RGC. And they want to compete with the Americans in order to show that Hong Kong has higher standing. So all of us are paying and doing all these things because we need prestige. So it's a prestige market. And this is the reason why it's not going away. I've decided for quite a few years that everything that I publish and I have control over, students that I work with, I only submit to Diamond open access that have no fees. Everything is open. I only go to community journals, community initiatives. But every year, HKU tells me, not good. How about these high impact factor journals? And publish more. Very difficult to get rid of this. Us early career researchers in the open science movement care about this, but the senior ones who have struggled for years in order to get to where they are and hold the power actually don't do much. So I hope you'll come at the end of October to listen to the librarians and listen to some of the speakers to understand just how big this is. This is huge and it's affecting everything that we do. Anyway, another thing that we can do is that we can also stop reviewing for them. Just like they said, we review each other for free and then we give away everything to the publishers. We can also just quit. So I don't review for any of the for-profit publishers. And it affects my reputation in the community and how much I'm likely to get promoted. Another big problem, and you should worry about this problem, because we think that academic research is solid because it has been peer-reviewed. It's a magic word, peer review. Right? What does peer review actually say? Somebody, we don't know who, read this, said something about it, and then the journal decided based on that, agreeing to this or not agreeing to this on these anonymous people, to publish the paper. Obviously, we just saw that they have an incentive to publish as much as possible because they make money out of it. Have you ever seen peer review on a paper? When you Google these things on Google Scholar and something comes out, how do you know why this was actually accepted? Have you seen the reviews? Do you know who reviewed this? Do you know how solid this is? Nothing is available. It's even worse than this. What's worse than this is that we don't have access to their data, to their code, to their materials. So what happens in cancer biology is that you start with 193, and at the end, you can only begin to replicate 50 of those. The problem is we don't share anything. So we actually don't know how did they run all these analyses. It's even worse than this. When I get invited to be a peer reviewer, I have a policy I signed. It's called the Pro Initiative. I signed a declaration that I will not review a paper that I don't have data and code we don't have access to. And many of them say, oh, you require data in code? We'll find some other reviewer. And like, who is going to review this without the data in the code? How do I even know what happened there? It happens in the journals. Actually, it happens in HKU as well. I'm a second examiner to a lot of undergraduate theses. Sometimes some stuff there seems, at the very least, as a mistake, if not much worse than that. So I asked the mentor or the student, can I please see the data in the code so I can understand? Maybe I can help you to make sense of this. We can see where this went wrong. So no, we can't share the data in the code. Can't share the data? How am I supposed to evaluate this? So peer-reviewed is a trust system. Science is not supposed to be a trust system. You're supposed to be able to evaluate each and every step of the way. This is not a cult. We don't just take things for people said based on reputation and prestige. So what if it's published in Nature and Science? I want to see what they did. I want to see the peer review. You said this is peer reviewed. Terrific. Show me what the peer review. Closed. We cannot identify the anonymous reviewers. We cannot tell you what the peer review was. You do not have access. You paid for this research as taxpayers. You have no access, not to the peer review, not to the data, not to the code. What kind of customer would agree to this kind of agreement? So on one side, for-profit publishers. On the other side, the journals and the academic system. You're not getting the value for the money that you're paying us. How can you trust anything, right? It should not be a trust system. You should be able to evaluate each and every step of the way. So you pay my salary, but you don't get access to my work. Can you review my research project? This is what they ask me. And I say, sure, can you show me the work that you've done? I said, no. How am I supposed to evaluate this? Horrible. Chris Chambers, one of the many people who advocate for open science, came out in 2015 with a book that we thought is about social psychology, saying 7 deadly sins of psychology. Since then, we know this is not about psychology. This is how we do science, and it's across all fields. If anything, it's much worse in other fields because nobody cares about social psychology, but a lot of people care about medicine. Pharmaceutical companies can make billions. Nobody makes billions from what I do. So over there, the incentives are even stronger. What kind of things do we have? What is the sin of bias? Outcome bias, confirmation bias, publication bias, hindsight bias. Publication bias is very, very strong. How do we evaluate? When I do peer review, when you submit your research, how do we evaluate your research? Only after you've completed everything, including the results. So I see the results, but should the results actually matter for how I evaluate research? It should not be about the results. It should be about the process. Was it rigorous? Are the methods solid? I'll give you just one example, and this happened again and again during the pandemic. Let's say that we have 100 studies on whether a certain vaccine works or doesn't work. We ran 100 studies. 2 of them worked, p-value lower than 0.05. We take all the 100 studies, we submit this to the journals. What do the journals say? 98 didn't work. This is not news. We can't do anything with this. A lot of things don't work. Reject. What do? We learn from this. So like, why would I waste my time submitting 98 things to the journals that didn't work? I'm just going to take this and put this in the file drawer so nobody will ever see it. What do you end up seeing? The 2 things that worked. Vaccine works. 2 out of the 100. You don't see the 100. You don't know that it's 2 out of 100. 2 out of 100 could be a fluke, right? What do you see? 100%, right? This is publication bias. Publication bias, outcome bias, hindsight bias. When you give out the outcome, then you create a problem because people are biased. So we have the sin of bias. We need to eliminate all of this. How to address half of these things? Just hide the results. Or even better, and this is what Chris Chambers introduced, and it's a magic pill to improve science, is to do registered reports. You don't submit the entire thing, you submit the pre-registration plan. And people review the pre-registration plan. And once everybody agreed together that this is the best plan, then you get an in-principle acceptance. And that means that no matter what the outcome is, positive, negative, p-value above or low, 0.05, it will get published. Then you eliminate all of this stuff. No more confirmation bias, no more any bias. Everything gets published. Then you know, as the taxpayers, what works and what doesn't work. So we have all these biases. Now, if we consider, at the beginning, we didn't really know what's happening in the scientific process because we didn't have meta-science. It's a very, very young field. But then we realized that throughout the life cycle, all of this life cycle, there are lots of issues. So let's just remember what is the life cycle for an academic study. You have generate hypotheses, then you design a study, then you collect the data, then you analyze the data, then you interpret the data, then you either publish this or you decide that you want to do another experiment, right? Now, for every step of the way, we know how serious the issues are. For example, nobody wants to do replications. So the first meta-scientific evidence from 2012 showed that only 1 out of 1,000 articles has ever been subjected to a replication. 1 in 1,000. Everything is novel. How can everything be novel? So something was published in the 1970s using 20 students from Princeton. Since then, it's in TED Talks, it's in books, it's communicated to you in courses. How do we know? Does it still hold? Is it still relevant 50 years later? If you run this with a big representative sample that's not Princeton students, does it replicate? If we run this in a different culture in Hong Kong, does it replicate? People say, no, it was published once in a top journal in the 1970s, enough. Let it be. Now we can communicate this till the end of time. This is not how we do science. 1 out of 1,000 is being replicated, or is a replication is a very, very bad signal. Another problem is low statistical power. We're going to talk about this. Very small samples, very, very noisy, not likely to replicate. Then we have something called questionable research practices. I'm going to demonstrate what questionable research practices are. We're going to p-hack together in order to bring the p-value lower than 0.05. How many people are doing this? When we ask them, we just ask, are you doing questionable research practices? Between 50 to 100% say that they're doing questionable research practices. Between 50 to 100% admit to doing questionable research practices. Selective reporting. Then people are doing harking. Then people are only publishing positive results. Big problem. So when we do meta-science, we realize what people are doing. And all of this is psychology. People are reacting to incentives. They want to publish in high impact factor journals and get promoted at HKU. This is what we do. How do we know that people do this? Because they tell us. We ask them and they tell us. So this is just a preview to some case studies that I will introduce to you. And I will just say that this started for us in social psychology in 2011 in a seminal study by one of the top social psychologists, Daryl Bem, that found and published in one of our top journals that people are able to predict and feel the future. So go refresh yourself, 5 minutes, come back, and I'll tell you about Bem. 5 minutes. Daryl Bem, the person who rocked social psychology world. So he's well known. He's from Cornell. Has written one of 4 that have written an introduction to social psychology. So very prominent. And he did this study. And in the study, you can see that he conducted 9 experiments with over 1,000 participants. So relatively, to that time, considered to be big samples. Only 1 out of the 9 did not yield statistically significant result, which means that 8 of them worked. So what he was showing is that people are able to respond to stuff that's happening randomly in the future. So typically in an experiment, perhaps you've participated in some of the lab experiments as a participant pool, or you got some money for it. Many times we go into a lab, they hook us up to measure our sweat and our heartbeat, maybe EEG, right? And then it presents stimuli to us. And then depending on what the stimuli is, our brain starts to fire. We start to sweat. Our heart starts to beat very, very fast, right? If we want to elicit very strong reaction from people, we use stimuli that has to do with fear, so to startle somebody. Or, and this is some of the stuff that they used over here, you use erotic stimuli. And typically when people see, regardless of gender, erotic stimuli, something happens. You know, there's an immediate reaction to this. Now, Daryl Bem decided to change this thing a little bit. Instead of seeing how the body reacts to something that was presented in the past, he wanted to see if he randomizes what is to be presented in the future, are people going to react to what is going to be presented in the future more if it's erotic stimuli. And he was able to show, deviating from randomness, from 50-50 chance, he was able to show that people start to sweat and react in heartbeat and EEG before the erotic stimuli is even presented, and it's completely random. Big shock. So we did not know what to make of this. This contradicts everything that we know about the world from physicists. This makes absolutely no sense. That a social psychologist is going to show physicists the nature of the universe, that people are able to react to things in the future, seems very unlikely. But why was it published in one of our best journals, the Journal of Personality and Social Psychology? Because we couldn't find anything wrong with it. We looked at the methods, and the methods are like, yeah, you did this right. We even went further. We asked him for the data, and he shared his data. No dog ate his homework. He gave us the data. We looked at the data. The data seems solid. It's not even fraud. So he didn't fabricate this. Looks to be up to date with our best methods from 2011. So if he's able to show evidence for something that we know is impossible using our best methods, then something is very, very wrong. Now, how do we check this? What should we do in order to see if this is right or wrong? We couldn't find anything wrong with it. Should we now change our view of the universe? No. What do? For the first time in a very, very long time, since the beginning of science, we started to do replications in social psychology because this was disturbing. We need to understand this. So we started to do replications. One of the first people is Stuart Ritchie over here. So he said, I want to find this. I want to run this again. He ran 3 of these things and just couldn't find the effect. So he submitted this to JPSP. What was the reaction from JPSP? It's a null result. You didn't find anything. It's not novel, and Ben did this before. Reject. Finally, he published this in PLOS1, which was the only journal willing to publish this kind of thing. When this happened, all of us, it's like, what is happening? JPSP is not retracting. It's not even publishing the failed replication. You need to go to a different journal that nobody heard about in social psychology to publish over there. So a lot of people, important people in social psychology came together, did another replication, and then submitted this to JPSP, and JPSP then published it. Did they retract the original one? They did not. Which one gets more citations? BEM gets more citations. Nobody notices the replication. So we've got all these failed replications published in different journals, but nobody notices them. So, some of the original stuff keeps getting cited. This is Stuart Ritchie. He wrote about this, about pornography, psychic pornography. And he wrote about his journal, about his journey with the journal in this beautiful book called Science Fictions. I strongly recommend this. It's a very good read, not just about them and psychic pornography, but about much more than that. And finally, 2 or 3 years ago, Stuart Ritchie decided he was a very prolific academic, decided to quit academia, and now he runs an amazing podcast called Studies Show. So when you write your chapter about science credibility, one of the things that you can refer to is Stuart Ritchie with Studies Show, where they take different topics and they look at the evidence and they try to understand, is this evidence solid or not? So I strongly recommend this, to look at some topics, look at their podcast and see what happens. Left academia. Big study in 2015, shook the world. Best news we could have hoped for. Do you want to lose weight? What's the best way to lose weight? Just eat more chocolate. So here you can see some of the findings. Scientists say that eating chocolate can help you lose weight. Has the world gone cocoa? Eating chocolate can help you lose weight. So every once in a while, we have this magic component. Goes viral on social media. Drinking 1 glass of wine a day will help you. Right? You don't need to go exercise anymore. Just eat chocolate the whole day and everything will be great. So a lot of newspapers love this. The Huffington Post. This really became a big sensation because people love this kind of news. Now, this is not fabrication. He really ran the study. It's based on scientific evidence, but he was kind enough in 2015, John over here, to write this blog post. And this is what he wrote. I fooled millions into thinking chocolate helps weight loss. Here's how. And he tells you the secret. So if you want to find something in your undergraduate thesis, guaranteed, this is how you should do it. So here's a little dirty science secret. If you measure a large number of things about a small number of people, you are almost guaranteed to get a statistically significant result. How do you do this? They actually measured 18 different things, not just weight loss. They measured weight, cholesterol, sodium, blood protein level, sleep quality, well-being, from 15 people. Very small sample, very, very noisy. 18 different things. Did they tell people about all the 18 things that they measured? No. Just the one that just out of the randomness of the universe came out as a fluke with p-value lower than 0.05. But even that was not enough because it was still not getting quite the threshold that they were looking for. So one of the subjects was dropped. They looked at which one was the outlier and then decided, oh, that subject had a headache that day, so we're going to remove him from the sample. And then all this together is a recipe for false positives. So this is outrageous. This is not what we want. Do people really do this in academia? This is just like a guy doing a hoax online, right? Scientists wanting to prove a point. Do people do this? Yes, they do this. How do we know? Because Daryl Bem gives them advice to do this. So for example, here, he gives advice to students like yourself, how to write the empirical journal article, planning your article, your study. Which article should you write? There are 2 possible articles. One is the article that you plan to write when you design your study, a pre-registration, right? Or The article that makes the most sense now that you've seen the results, these are rarely the same, and the correct answer is B. Actually, when I was doing my PhD, this was generally the advice. So around the time of Daryl Bem, this was very common advice, but the answer is not B. B is anti-scientific. The correct answer is A. Why is B more relevant for him? Because he wants things to be more exciting. Then he can predict the future with this. He can show that people actually feel the future. That makes psychology a lot more exciting because you can find all kinds of things that are counterintuitive. Not just him, but other people from Ivy League universities like Harvard give this kind of advice, you know. What you don't have to do is tell the whole truth. You need to tell the truth and nothing but the truth, but not the whole truth. In other words, you can select the results you present. Out of the 18, just select the one that worked. No, you cannot. So even Daryl Bem, even Ivy League professors, this is not scientific. So you need some early career researchers that want to commit academic suicide to write as a comment to this: selective reporting strongly biases our understanding of the way the universe works and borders on scientific misconduct. To write something like this to someone like that, and Daryl Bem, you need a lot of guts to do this kind of stuff. Priming. Every year, I see at least one undergraduate student does their undergraduate thesis on social priming. And I beg you, please do not, because we have a lot of problems with priming. Priming is this idea that if you activate a certain mindset by unscrambling sentences or doing a recall task or something that activates a mindset, then your behavior changes after that. One of the classic findings about this is Sewell and Wire from 1979, over here, cited by, and this is from a few years ago, 2,463. A lot of citations, a lot of conceptual replications, a lot of people that have found this again and again. So question is, will it replicate if we run this again? For many, many years, nobody decided that this is worthwhile to, because these are very prominent researchers. One of them actually was based in Hong Kong at HKUST in the marketing department, recently retired. So yeah, just take it for granted that this stuff works. And a lot of undergraduates decided to follow up on this. But Randy McCarthy, together with all these people, many of them who I know from the open science movement, decided to replicate this again and again in many labs from around the world to try and repeat this kind of study. What did they find at the end? These results suggest that the currently used methods do not produce a priming effect. It's not practically and routinely detectable. You cannot find social priming studies here. What they did is they unscrambled sentences about hostility, and then they found some measures, but we couldn't find this. Only when we conducted this replication did we find some other things very troubling. So here you can see from the Twitter account, or X, Randy at the time realized that some of the effects are just too good to be true. They're too large. They're impossibly large effects. He realized this because you need to do a power analysis when you conduct a replication to know how large your sample is. And then he also looked at a meta-analysis that showed that the effect size, first of all, only 80 participants, and you'll see how many conditions there are over there. A lot of conditions. This is a four-way interaction. So 80 participants with a four-way interaction with an effect size of Cohen's d 5.6. A Cohen's d of 5.6. Just so we understand what is 5.6, getting anything above 0.8 or 1 is just very, very difficult. It has to be like a manipulation check. But just to give you an example, Randy makes the comparison that a Cohen's d of 5.65 is a little bit like Shaquille O'Neal from the days of the early NBA, our days, the NBA compared to the average female. It's this noticeable. So a slight social priming, hostility priming, just unscramble some sentences, creates this kind of difference between impossible. Now, when we looked at this meta-analysis, we actually realized a bunch of other stuff, which is very troubling. So you can see social priming literature not only has Sewell and Wire with impossibly large effects, but also has this Stapel. Who is Stapel? Diederik Stapel. Diederik Stapel was the dean of social sciences in the University Tilburg in the Netherlands, who was found and admitted to fabricating everything since his PhD. Everything that was published in Science and Nature and all of our best journals, everything is fabricated. So all of these, all this Stapel stuff, he just sat with wine at home and just like recorded some of the findings. So some of the open science movement people are the people who detected his fraud and got him kicked out. And this is why the Netherlands is now one of the leading proponents for open science in the world, because they were so ashamed that a dean of social sciences does this. Where did he publish? In social priming literature. This is what the literature looks like. But actually, you didn't even need to do this in order to understand that there's a problem with this very prominent paper, because you've got a four-way interaction, I don't even know how to look at a three-way interaction. Two-way interaction is a little bit difficult for me, but I can grasp. Three-way interaction, I can rarely understand it. Four-way interaction, impossible. And then with 80 participants, to get a p-value lower than 0.02, creating this perfect figure is impossible. So if you just sat and read this, rather than trust, then we would have seen this before. If we would have opened this up, if we would have run replications before 2015, then we would have seen this. Just imagine all the poor undergraduate students at HQ trying to do social priming for the thesis, spending years on this. So sad. Every year I see this. Here you can see the meta-analysis. So this is a meta-analysis of all the labs. What you can see here is that you see the null effect. This is the dotted line over here. This is for each study the confidence intervals. If the confidence intervals do not overlap, like happened with the initial one over here, then there is a big effect. But you can see that most of the labs, perhaps aside from this one, most of them include the zero. See? All this includes the zero. So if you aggregate all of these together, this is the aggregation, and it touches on the zero, and the effect size is not 3 or 5. The effect size is 0.08. Because it overlaps with the null, we don't consider this to be an effect. Not just this one, but also the second one with this effect actually goes in the opposite direction, but also touches on the null. So all these labs, a lot of investments from all of them. People who do not get promoted or acknowledged for doing replications decided to do this. What was the conclusion? No, you did this wrong. The replicators don't know what they're doing. If they did this correctly, then they would get this. So poor Randy had to do this again. He did this again in 2020. He got more labs from around the world. This time, he did two things. First, he ran this as he did in the first one, and then he ran this together with social priming people in order to try and work together with them in order to get the social priming. Now we're talking about not just doubling, tripling the amount of money invested in this. What is the bottom line? The hostile priming effect for both the close replication and the conceptual replication were not significantly different from zero. Despite our best efforts to produce favorable conditions for their effect, we did not detect. We suggest that researchers should not invest more resources into this. Enough with this. All this is from 80 participants from 1979. All of this, what a waste. Did we really need the second one? We already saw that there's some issues, but no, replicators don't know how to do research because there's a published finding, 1979. Heartbreaking, poor Randy. Do you think he got acknowledged for this? You think he got promoted for this? So we had a lot of issues. Nobody noticed for decades obvious errors, impossible effect sizes, and figures that are too perfect. And then there's no correction. The article is still there, getting more citations than the two replications. Nobody's taking this down. I don't really understand why. Nobody has conducted for a long time direct replications. Too large scale, millions of dollars invested. A lot of researchers, years of study, just to try and get the other thing reversed, and they even couldn't do that. So priming literature is just, we did this many times, not just Randy. Open science community did this for every one of those. Finally, today it happened, but finally this was retracted. Finally. Why it's retracted? Because they cannot prove that they even ran the study. They don't even know who ran the study. It's an amazing case study. Maybe we'll get to this when we discuss fraud at the end. But all of these fail to replicate. All of these are mass collaborations with millions of dollars spent with many dozens of labs from around the world. So social priming, please don't do this. If you know anybody who's doing social priming, please get them off this. Priming in cognition, so cognitive science is great. Social priming does not work, okay? How does John Barge, one of the fathers of social priming, how does he react to all the failed replications? No, things work. Even more than this, he still gives TED Talks and publishes books. This is from 2018. Before you know it, the unconscious reasons we do what we do. I don't understand this kind of behavior. Still a prominent, full professor, senior editor on stuff. I really don't get it. So here's a meme for you to kind of spice things up for you. And many of the things that you'll see here, I have actually seen people do. I know that people do this. And I'll show you meta-scientific evidence that people are doing this. This is a meme. I don't know, have you seen this before? Have you seen this guy before? So this is actually from a Mexican TV show. It's in Spanish. And they're talking about something else. They're not talking about science. But you know these things where you put some other subtitles in order to ride on this, right? So people in the open science community gave this different subtitles. So this is not what they're saying, but this is just to make a point on how researchers act when it comes to submitting papers to publication.
Y me llama el cocinero. Risita, ¿qué? Ve por la paellera. Venga, que a las 2 de la tarde ya están aquí. Mira el bañador, las chanclas. Todo despeinado porque no me dio tiempo nada ponerme las chanclas y el bañador. Voy a la playa, había subido la marea. quiere agarrar, él se metía entre las piedras de chipiones del faro. Y cuando entra en el restaurante me ve el cocinero con una paellera y a ver solamente paellera. ¡Asómate, mira dónde llega el agua! Llegaba el agua del restaurante, había subido la marea. Jesús, hay que hacer ahora con los dos sacos de arroz. ¡Ay, llama para Sevilla! ¡Llama a Sevilla que traigo un país! Jesús, yo con el bañador y con la paella. El cocinero, no vea, a Sevilla. Y al último que cuando ya salió la bien de regla, estamos llorando los dos. Me cobró el tío la paella. Me cobró a 500 metros. Y ya no fui más. Me fui andando con los amarillos hasta hoy. Me mandó por la noche, había bajado más el agua y por la mañana había subido. Cualquiera estaba dónde está la paellera, ¿sabes? A lo mejor está en el barco ese del petróleo.
En el Prestige.
En el Petrillense.
Yeah, our sad reality. This really happens. And I'm going to show you how we do this. We're going to hack our way to glory. If you want to know how to get your undergraduate thesis to always have p-value lower than 0.05, then here's the magic component. There's 4 different apps. I don't have the time to show you all of them. I just show you one of them. And it's called the p-hacker. So this runs on R. Don't know if you're familiar with R, but R has ability to create a shiny app, it's called, that gives people who don't know any coding or don't know any statistics in R, gives them an interface. So this is the interface. In the back, there's a lot of simulation. So this is how it works. Let's say, for example, that we have an experiment. And in this case, we're going to call this social priming. So we have the social priming condition, and then we have the control condition. And then they ask us how many participants in each condition. So we're going to keep this as 20 because this is the common one in social priming. True effect of 0. True effect of 0 actually means that everything that's going to be simulated here is random noise. Should not be any effect. If you see any p-value lower than 0.05, this does not indicate any effect because there is no effect. The simulation is supposed to simulate 0. Number of DVs, we're going to do just like in the chocolate study. So we're going to put this into the maximum. And then we're just going to run this study. So everything that you see here is just random noise. We have 10 different variables. And here we have the statistics running on these variables, so 20 in each condition. And then we see their p-values, right? So already you can see, just by the randomness of the universe, that one of them gets pretty close. So here we have DV number 7 at p-value 0.085. Now, the nice thing about this is that it already knows to detect my best DV, which is DV number 7, and it gives me a scatter plot of this kind of thing. And now I look at this because I want to understand why it didn't work the way that I expected. How can I get this published? And then I realized that this one here is the problem. And when I look this guy up, I see that he was sick that day. So I'm just going to take him out, okay? So if I press this and I go back to DV number 7, then I can see that finally I have p-value lower than 0.05. And then I can submit this to Nature and Science, and then I can get my paper published. I don't even need to say that I took this out as an outlier, right? Don't need, in some of the disciplines, it's still acceptable for you not to report everything or how you decided which ones need to leave. But let's say that we didn't do this because BEM did not do this. BEM did something different. How did BEM show that people are able to feel the future if he did not play with outliers and he had big samples? How did he do this? So I'm going to show you one of the hacking techniques. Actually, in 2011, we did not understand the statistical implications for this. We were very naive. And actually, I know a lot of people who used to do this. In some disciplines, people still do this. And I don't understand why. They're not better informed. After in social psychology, we've known since 2011 that this is a big problem. So we have this tab over here. It says now p-hack. And you'll see that what I'm going to do is that I'm going to add participants. So what you're going to see is that we add participants and then we peek. We look at the results and we see the p-values. We're going to add participants and peek. We're going to add participants until something happens. And now you're going to witness something miraculous, and it's called the dance of the p-values. Turns out that's just because the way the p-values are, they're going to dance. They're going to go up, they're going to go down, and at some point, Just because p-values are like that, one of them is going to become significant. So let's play with this. I'm going to add, so first of all, see this one, 0.085. What's going to happen if I add 10 participants? I'm going to add 10 participants. What happened? P-value disappeared, right? Now it's really worrying. Maybe I won't be able to publish in Nature. So I'm going to add 10 participants. Nothing happens. They go up, they go down. Add 10 more, go up, go down. 10 more, 10 more. And suddenly, DV number 1 seems very promising because it's getting closer to, then I'm going to add 10 more. Now it's getting really close, 0.06. So that looks promising. I'm going to add 10 more. No, disappear. Maybe I'll keep going. Keep going. And then suddenly DV number 9 seems promising. I'll add a bit more. Ta-da! So after running 240 participants, finally DV number 9, without doing any exclusions, DV number 9 is significant. So we have some labs. For example, when we bring in babies or we bring in neuroscience people into the scanner, sometimes it's very tempting to I just want to see the results. I just want to see where I am. Should I run more participants or not? So bring one person, look, p-value are still not, okay, next person, look, next person, look. Actually, there are implications for that because every time you do this, you increase the chances of you finding p-value lower than 0.05 because of the dance of the p-values. It's even worse than this because I can keep going with this. And actually, if it's not enough for you to get into Nature with one significant, you can keep going. And just because of the randomness of the universe, it might happen that we get another one. So we add another 10 participants. Ta-da! Now we have DV number 7 as well. So now, for sure, I can get published, right? This is what's called optional stopping. You peak. So Feldman would bring somebody into the lab, would see, oh, p-value lower, oh, still not, okay, next one. Would look. So he has admitted on a podcast that this is what he did back then. And a lot of people are still doing this in some disciplines. In social psychology, not. Now we have something called a pre-registration. But in HKU, we still do not demand of our students to do a pre-registration. So in a pre-registration, you need to say in advance when you're going to look at the data and not look at the outcome and then decide if you're going to keep running or not. Okay? You can do optional stopping, but every time you look at the data, you need to compensate in the alpha. So you need to divide the alpha by 2 in order to battle the dance of the p-values. Second thing I'm going to show you is the p-checker. And this is something that I recommend to all of you doing a thesis. If you want to know whether what you're doing is based on solid foundations, take the entire literature and do your own meta-science. How to do this? You can actually extract the p-values from the papers, or you can copy-paste this manually. And you can put all the p-values or the statistics here on the left. And this tool, the p-checker, will do the meta-analysis for you and tell you if there's a problem there. So there's already some data sets here. So I'll show you the data sets. So for example, the demo data we have on all sorts of things like power posing or elderly social priming. So I'm going to show you the elderly social priming. So Lakens already did a big service for us. And the big service for us is that he put in all of the studies and their p-values over here. And now that we have this over here, first thing that we can do is that we can check whether the p-values are correct or not. Did they report this correctly? So we have a tool called StatCheck. And this StatCheck is embedded in this tool. So if you go to p-values correct, it would check all of the p-values. And in some cases, it will tell you if there's a problem with the p-value. The p-value was not calculated correctly. Or maybe they reported a 1 tail when they should have reported a 2 tail. Right? So already it gives you an initial examination of what's happening in the literature and whether they did reporting correctly or not. Then you can do a meta-analysis immediately with one click. You don't even need to know how to program because this is a Shiny app for you. And it will give you a distribution, what's called a funnel plot of the entire literature. Now, I know that you are not proficient in reading this, so I will just tell you that generally having the values like that is indicative of publication bias, because if this was true effect, we've got the triangle under the effect of 0.5, which is the expected effect, then the points should be all over the place. They should be all over the triangle just because of the randomness of the universe. But here, in this part here, we have a lot of missing values. The reason why they're missing is because we have another triangle that shows no effect. And nobody has published these. So when we don't have the missing dots here, this is indicative of a publication bias. And then we have all sorts of other kind of measures to show us a publication bias. We have Egger's test to show a publication bias, p lower than 0.001. We have a PET piece estimator of a publication bias and so forth. In addition, we have something called a p-curve. So if we see that there's an excess, there's too many p-values just below 0.05, then it seems like people are pushing their p-values to be lower than 0.05 by doing all sorts of questionable research practices. So what should happen is this green. I don't know if you can see this green. So most of the p-values need to be close to 0.00, less 0.01, less 0.02, less 0.03, and the lowest should be 0.05. What happens with elderly priming? Most of them, 44%, are just below 0.05. So that's indicative of p-hacking. We also have measures to look at this. So if there is evidential value, is it inadequate? Very inadequate. Is there any indication that this is intensely p-hacked? There is indication that this is intensely p-hacked. So just by putting all the p-values on the left, you can run with this Shiny app and see how solid your literature is. So use these tools. They're very, very handy. Now we understand how to evaluate these kinds of things. Do people really do what this guy in the video was saying? We ask them, and when we ask them, they actually tell us how many people fail to report all the dependent measures. We ask them to self-report, 78%. Then we ask them, how many people do you know are doing this around you? 100% people are doing this. This is from 2012. All of the other questionable research practices, rounding down p-values and so forth, all of these people are doing questionable research practices, and we know this because they tell us that they're doing this. Even with fraud, 2% are admitting to do fraud, and then they're thinking that 10% or people around them, 30% are doing fraud. 10% around you are doing fraud, and you're saying nothing? How is this even possible? So we have a lot of indication from meta-science evidence that people are pushing. There's too many values just below 0.05. It's not supposed to be this way. All this is okay. All this distribution of p-values is as expected, but this one makes no sense. People are pushing and playing with the p-values. How many people, the most recent survey in the Netherlands, which is the #1 in open science in the world, how many people are reporting to doing fraud? 4.3, 4.2. A decade after Diederik Stapel, the Dean of Social Psychology in Tilburg, 5% are saying that they're doing fraud. How many are saying that they do questionable research practices? 51.3%. Then we aggregate this. We have a lot of studies looking at questionable research practices. Look at all these rates. Some of them are getting close to 50%. This one, 60%. Optional stopping. How many people are doing optional stopping? Look at all this. People are still doing this, even though we know it's questionable research practices. Horrible. What are the costs? It costs us billions of dollars, not Hong Kong dollars, US dollars. And then we see what the cost is for all of us. This is stuff that we can invest in order to fight climate change, in order to get over pandemics, fight poverty, and so forth. What to do about this thing? We can discuss this. We have a whole course to discuss this kind of thing. But my summary of the situation is that we need to talk about these things and we don't talk about them. Some people disagree with me, and then I say, okay, it's okay that you disagree with me. We can have a discussion. But at the very least, let's just work on creating a better world and better science by doing all these things, by just improving science. I'm not going to go into this because we're running low on time. I'm just going to say up until 3 years ago, we, the open science folks, were on our own. But 3 years ago, we got a big boost from UNESCO. Finally, UNESCO said open science is important. So UNESCO came in and they had a call in 2023. Since then, we had even NASA declaring 2023 as the year of the open science. In the end of October, we're going to have Open Science Week in the library. And then even here at HKU, we had a conference, World Conference of Research Integrity. The entire world came here and has something that everybody refers to as the Hong Kong Principles of Open Science and Assessing Researchers. Many universities around the world are following this. Who is not following this? We, HKU, we're not following this. We hosted this. We're not following this. We didn't even sign this. Hong Kong principles, but Hong Kong does not follow those. I don't know why. So we need to implement open science. We're going to talk about what open science is. You're going to have a tutorial very soon, by the end of the week, to supplement the tutorial that is already posted on the syllabus on how to evaluate what is credibility, what is open science, and then we're going to discuss this pyramid. So right now, the evidence that we have for most of the things is not barely worth a mention. It's anecdotal. But as we move up in the open science, when we have pre-registrations, when we have open peer review, we have open data and materials, when we have all of that, we're going up and we're getting closer to the green. And then we can start to inform policymakers, not with what we have right now. Even if it has thousands of citations, that doesn't mean much. So we have a lot of resources for you. We're going to train you with those in tutorials, in follow-up, in some of the lectures that are to come, and we're going to write a book together. We already have a collaborative guide, so you can go over here and check this out. We also have something that will train you on some Google Sheet in order to use that. We also have effect size guide, so that you'll know that when you see an effect size of 5.6, that this does not make any sense. So we have a lot of tools for you. We'll train you in how to do this, and we're going to write this book together. So all of the resources, everything that I just talked about is on my website. You'll get to know this a little bit better, and you're going to work together with me in order that we would understand what it means to have credible evidence, and that we can help others in the community understand what is credible articles, what is credible scientific evidence, and what is not. Okay? All right, just a teaser, more to come. I'll see you next week.